Go for launch.
Vehicle is supersonic.
Stage separation confirmed. Dragon separation confirmed.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello, everyone, and thanks for joining us for today's PSN SATRIA mission. My name is Ronnie Foreman, and today we'll be following Falcon 9 liftoff from Space Launch Complex 40 in Florida to take the SATRIA satellite to a geostationary transfer orbit. Although I'm joining you today from our headquarters in Hawthorne, California, our rocket and spacecraft, as you can see on your screen, are preparing for liftoff on the opposite side of the country. Right now, you're seeing a live view of our launch pad in Florida. As I mentioned earlier, our customer for this mission is PSN, which is an Indonesian company. If you're unfamiliar, Indonesia is located in Southeast Asia, surrounded by both the Indian and Pacific Ocean. It's also an archipelago, which means the country of Indonesia is comprised of more than 17,000 islands. Being an archipelagic country with mountainous topography means Indonesia is one of the world's most challenging territories for telecommunication infrastructure. Second capacity, supported by very high throughput satellite, or VHTS technology. That will not only promote digital equality, but also economic growth as it becomes increasingly pivotal in a post-pandemic economic recovery. Now, at T-minus 9 minutes 34 seconds and counting, we're well into propellant loading on the vehicle today. Both the rocket and spacecraft are healthy, and weather is green. Of course, the range is also standing ready to support a liftoff of 6:21 p.m. Eastern Time. But if for some reason we don't launch today, we do have a backup opportunity tomorrow.
Hey everyone, Soumya Srivastava here, joining Ronnie to guide you through the PSN SATRIA mission today. The rocket on your screen is Falcon 9 and gets its name from the Millennium Falcon from Star Wars and the 9 Merlin engines located at the very bottom of the vehicle. Standing at around 230 feet tall, Falcon 9 is loaded up with nearly 1 million pounds of fuel and liquid oxygen prior to liftoff and is able to transport payloads like today's satellite and people to various orbits in space. To top it off, Falcon 9 is also the world's first and only reusable orbital class rocket. The F9 rocket you see on screen is made up of two main stages. The first stage, or booster, which is the largest section towards the bottom, and the second stage, which will eventually take up our payload to its destination in space. You might be able to tell from the soot around the bottom that the first stage supporting today's launch has seen its fair share of space travel. That soot that you see all around the first stage is formed when the carbon-based fuel we use, RP1 kerosene, is burned. And as the booster approaches the landing site during descent, it does a long re-entry burn to slow down prior to re-entering the atmosphere. And because the re-entry occurs engines first, the booster flies through its own plume, which then deposits the soot onto the rocket. And if you watch the feed from the onboard camera during landing, you can see the soot sticking on the lens. Flying for a 12th time today, a few minutes after liftoff, we'll be attempting to recover the booster once again on our drone ship, a shortfall of Gravitas. And as mentioned, there are 9 M1D engines at the bottom of the booster that are used to accelerate the vehicle through the Earth's atmosphere. Moving up, the first and second stages are connected by the inner stage, which has pneumatic pushers that allow stage separation during flight. The inner stage also houses the Merlin vacuum, or MVAC engine, that's connected to the second stage. The Merlin engines at the bottom of the first stage and the MVAC are nearly identical, except the MVAC engine has a larger nozzle that allows the second stage to perform better in the vacuum of space. And we'll probably have some really great views of the MVAC and planet Earth after liftoff, so stay tuned for those. And at the very top, we have the payload fairing. The fairing's job is to protect the payload from aerothermal loads, heating, and contamination during ascent. Much like our first stage, we recover most fairing halves and use them again on future launches. The fairing halves supporting today's mission are also flight-proven, with one half flying for its 7th time and the other its 9th. Once we reach the vacuum of space, the fairing halves will separate and we'll attempt to recover them again using our recovery vessel, Doug. Now, with liftoff in about 6.5 minutes from now, let's learn a little bit more about the mission at hand.
Today's launch actually marks SpaceX's 240th overall mission and our 128th mission from the launch pad on your screen. In fact, of the 40 launches we've had already this year, more than half took flight from Slick 40. Located at the north end of Cape Canaveral Space Force Station in Florida, Space Launch Complex 40 was leased to SpaceX in 2007 after supporting numerous Titan launches for the U.S. Air Force between 1965 and 2005. Since then, we've had a total of 193 launches from Florida's Space Coast, with about 65% of them, or 127 launches in total, lifting off from Launch Pad 40.
Thanks for pressing for strongback retract.
SpaceX is planning on building a crew tower at Slick 40 as well to be able to launch future crew and cargo from this launch pad, in addition to 39A, which is bringing us another step closer to making humanity multiplanetary. Now at about 4.5 minutes to go until liftoff, we should begin to see that
Strongback retract in progress.
there's the call out for that strongback retract, and you can start to see the TE clamp arms opening up around the base of the fairing.
You can now see those clamp arms opening up, and as Ronnie mentioned, once the clamp arms are fully opened, the TE, which is hinged, will retract away from the vehicle in preparation for launch. You'll also hear it referred to as the strongback over the nets. And at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both the first stage and second stage should finish loading propellant about a minute apart from each other. The first stage finishes up at about T-minus 3 minutes, and the second stage at T-minus 2 minutes. You may have noticed the white clouds around the vehicle. Those clouds are actually vented chilled gas from above the LOX tank liquid surface that we vent overboard to maintain pressure in the tank as needed. And when that gas comes out into the Florida air, the humid air condenses into those clouds that you're seeing. And then at T-minus 60 seconds, Falcon 9 will be in startup. And that means that the rocket's autonomous internal flight computers will have taken over the launch countdown. And there was that call out there for stage 1 LOX load completion. And just inside of T-minus 2 seconds, we light the Merlin engines for liftoff. The PSN SATRIA payload continues to be healthy, and the Falcon 9 team is currently tracking no issues on the rocket.
So again, the next major milestone we are tracking is final LOX load completion, at which point Falcon 9 will be fully loaded with both fuel and oxidizer. Picture perfect day on the coast of Florida, too.
Stage 2 LOX load is complete.
There's confirmation that we are fully loaded with fuel and oxidizer ahead of today's launch. And fun fact, at liftoff, Falcon 9 will be burning about 700 gallons of that fuel per second.
Ground gas closeouts.
As some of you mentioned earlier, that white cloud that you see venting away from the rocket is totally normal and nothing to worry about. The next call out we're listening for is also one she explained to you. That's going to be that Falcon 9 is in startup mode and that the internal flight computers have taken over the terminal count.
Falcon 9 is in startup.
The final milestone we're listening for on the nets is the call out from the launch director that we are go for launch.
SLD on countdown. Go for launch.
There you hear it. We are just over 30 seconds from liftoff, and all systems are go for the launch of Falcon 9 and the SATRIA payload. Go Falcon 9, go PSN.
T minus 30 seconds. Seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Falcon, go PSN. Stage 1 propulsion is nominal.
Vehicle is pitching downrange.
That incredible view means that Falcon 9 has successfully lifted off from pad 40. And right now we are throttling down to prepare for max Q in about 30 seconds. As you may have heard us explain before, this is the period of highest aerodynamic pressure on the vehicle.
Power and telemetry nominal.
That's because at this point, we are seeing the greatest difference in dynamic pressure, which is increasing with the rocket's speed, and ambient static pressure, which is decreasing as we move up through the Earth's atmosphere.
Vehicle is supersonic.
With that call out, we know that Falcon 9 is moving faster than the speed of sound.
Max Q.
With confirmation that we've passed through max Q, we have 3 events coming up in quick succession, starting with main engine cutoff, stage separation, SES-1, or second engine start 1. Main engine cutoff, or MECO for short, is where all 9 Merlin 1D engines will shut off to slow down the vehicle in preparation for the next event, stage separation, or stage sep for short. That's where the first stage booster will separate from the second stage. Right after stage sep, the first stage will start its journey back to Earth, targeting a landing on our drone ship, a shortfall of Gravitas, which is currently stationed in the Atlantic Ocean, about 680 kilometers downrange. Now, during that time, Stage 2 will continue on its journey to space with the third event, Second Engine Start 1, or SES-1 on the nets, and this is where the single MVAC engine will ignite to propel the second stage along with the PSN SATRIA payload to orbit. In addition to these 3 major events, the fairing halves will also separate less than a minute after SES-1, so keep an eye out for all of those coming up in about 10 seconds.
Main engine cutoff.
Stage separation confirmed.
MVAC startup.
So you heard the callouts there, and you can see on your screen in this great dual view that we have that the MVAC engine on our second stage has ignited. Now, this is the first of 2 second stage burns that we're tracking for this mission. And the first stage on the left-hand side of your screen is coming back to land on our drone ship, a shortfall of Gravitas. Now, we are also expecting fairing deployment.
Both vehicles are on nominal trajectories.
With that, we know that both vehicles are headed in the right direction. And as I was describing earlier, we are expecting fairing separation in just about 5 seconds.
Fairing separation confirmed.
As some of you mentioned earlier, reusability is part of our secret sauce here at SpaceX. So with that confirmation of fairing separation, we know that both of those are coming home again. The first, or one of them is flying
Acquisition of signal Bermuda.
for the 7th time and the other for its 9th.
It's now T plus 3 minutes and 55 seconds into today's mission, and we have a great view of stage 1 on the left and stage 2 on the right. In order to complete today's landing, the first stage has 2 more burns left. Next up will be the entry burn, where 3 of the Merlin engines on the first stage will reignite, and this will help slow down the F9 first stage as it re-enters the upper part of the Earth's atmosphere. That entry burn should start in about 2-ish minutes from now and will last about 20 seconds. You can see 2 of the 4 hypersonic grid fins that are positioned near the base of the interstage on the booster. And stage 1 is currently using nothing but the grid fins for steering as it's returning back to Earth. You can also see those little puffs of gas. Those are nitrogen gas bursts for attitude control, and they also help orient the rocket on its way back down. And some really awesome views of planet Earth behind stage 2. And again, that entry burn on the first stage coming up in about a minute.
Both vehicles are on nominal trajectories.
Like I promised, we have great views of Earth behind MVAC and behind the first stage as it's coming back down to Earth.
Stage 1 entry burn startup.
You can see that 3 of those engines have now relit engines 1, 5, and 9 for the entry burn. It's about 20 seconds for this burn.
Stage 1 entry burn shutdown.
Now, with confirmation of entry burn shutdown, we have one last burn before the first stage attempts to land on our drone ship, and
Stage 1 FTS has saved.
and that is the landing burn. During the first stage landing burn, a single Merlin engine, E9, will relight and slow the vehicle down for its landing attempt on our drone ship, a shortfall of gravitas. As a reminder, the booster supporting today's mission has now flown for its 12th time, having previously supported CRS-22, Crew 3 and Crew 4, Turksat 5B, CRS-25,
Terminal guidance.
Eutelsat Hotbird 13G, O3B mPOWER, and 4 Starlink missions. We'll also be coming up on SECO-1, or second engine cutoff 1, in about 30 seconds from now.
Stage 1 transonic.
Stage 2 FTS has saved.
You can see that MVAC continuing to glow bright orange until SECO-1.
Nominal orbit insertion.
MVAC shutdown.
Great callouts for SECO-1 and nominal orbital
Stage 1 landing
insertion.
burn.
detected loss of signal, Cape Canaveral.
There's that view of landing burn.
Stage 1 landing leg deploy.
And a great view of landing. This landing marks the 12th successful landing for this particular booster and marks our 201st overall successful recovery of an orbital class rocket. In addition to landing with confirmation of successful second engine cutoff and good orbit, we are going into a coast phase up until the second relight of our MVAC engine on the second stage, which will be followed by payload deploy. Till then, sit tight and we'll see you back here at the T plus 27 minute mark.